All working fine? Cool. So I chose an article, actually the first article that linked mosquitoes as vectors for disease. This is a pretty cool historical article. And another reason I chose it is because I'm in robotics, and the articles that I typically work with don't pertain well to the setting, the things we want. So I choose weird articles. So 1881 by Dr. Charles Finlay. Here's some background on yellow fever. It looks like this. That's a picture. An etching from 1892. That's what it looks like. And the reason it's called yellow fever is because it's associated with jaundice. If jaundice gets yellow fever, well, that's yellow fever. And symptoms include normal flu-like symptoms, jaundice, internal bleeding, shock, organ failure, pain, death, misery, woe, acting internal organs. Considered awful. And if you look at the footnote of the paper, it lists an interesting fact. A contemporary paper to this one suggests that the cause of yellow fever is disturbed electricity. And it proposes that telegram operators were the ones that were starting. So this is Charles Finlay, born 1833, died 1915. And the contents of this article take place in Havana, Cuba, right below Florida. So the rest of, until we get to the experiment part, we also need to go through the background part of the paper. One of the reasons I really like this paper is it goes through a lot of the detective work that safety people have to do. We don't see a whole lot of that in the articles we typically see. So I'm going to go through and give really brief summaries of the paragraphs of the paper, because that brings out the meat of the paper, detective work, the brilliance that goes into this idea of mosquitoes.
Hey, Colin, would you mind adjusting the mic on your lapel a little bit? It's coming through a little patchy. I wonder if it's the placement.
Yeah, but I've noticed that through the past two.
Yeah, no problem with it.
You want me to speak loud then, or keep using it?
Loud.
You want him to turn the mic off?
No, I think just speaking a little loud.
Okay. Mic on, speak loud.
Okay, introduction paragraphs. The initial theory at the time is that things like the weather and hygiene were the main causes for spreading of yellow fever. Including Finlay, he worked on that idea for a bit. And then he notes the paper is on the propagation of yellow fever rather than origin. If things are in bold, they're especially important. He notes that yellow fever spreads across oceans to vastly different climates, yet at the same time doesn't spread to neighbors of the same climate. And so he also notes that the weather does seem to affect yellow fever. If things are more muggy and hot, there's more yellow fever. So he notes that the yellow fever vector must be affected by climate. So his hypothesis is mosquitoes. Mosquitoes are spreading the yellow fever virus. So he studies mosquitoes. That's a mosquito. Mosquitoes are everywhere, and they tend to spread with ships across oceans. Mosquitoes dislike high areas, so if you're camping, he thinks that you should sleep in a tree and get less mosquito bites. I'm not sure how that's true, or how true that is. He notes that. And he notes that mosquitoes have been around since forever. He observed two types of mosquitoes in Havana, the cubensis and the mosquito. More background, he goes over some anatomy. He notes the cubensis mosquito bites only at night, while the mosquito bites at day. And he performed an experiment where they put a cubensis into a glass container and then held it to the sun, and then the mosquito died. So that's why the mosquito bites died. Only females sting when it's fecundated. And so he performed an experiment to demonstrate this. So he had a non-fecundated female, and he couldn't get it to sting himself. But if it was, then it would sting. He noted that the fecundated females would lay eggs. And so this came to his hypothesis that, well, cheaters, they suck blood for incubation eggs rather than for their nourishment. It's true. That is why they suck the blood. And so he Also found that the larger cedars were only seeing once, the smaller ones more often, in theory because it needs to get more blood to do more of the incubation process. After laying eggs, mosquitoes die, presumably so that the larvae could eat them. And then he performed an experiment where he stung himself with a mosquito lots of times and it laid eggs. Great. So the hypothesis is that mosquitoes are yellow fever vectors. He also hypothesized that bigger cedars, taking more blood, are going to transmit yellow fever more often and with worse symptoms, but that's not tested by studies. He then talks about cedar statter anatomy, the cedar stabber. And then a little bit more background on cedars. He notes that cedars, he hypothesized that cedars would hibernate, and that's how they can travel to lots of places. They would be on clothes, be ships, and then those would go to different climates, and people would get yellow fever, even though there wasn't yellow fever before. The hiding places, sleeping. He also observed that cedars bite white people more than black people. And he introduces two counter hypotheses to his hypothesis that, well, maybe the cedars will suck some blood, they'll get some yellow fever, and then they die, and the yellow fever would spread through the air. And then another hypothesis is that they would die and excrete the yellow fever into your food and water. That's how it would work. But he says, well, no, because like smallpox, it's a blood-related disease, but needs to be coming from the blood to the blood. He then restates his hypothesis. And then he observes that meteorological conditions favor both the yellow fever and the cedar. Hot and muggy, you get more cedars, and you get more yellow fever. So that works nicely for his hypothesis. He then goes over a case study on the steamship Plymouth. It didn't have yellow fever, then it did. It wasn't allowed to board. So there must have been mosquitoes hibernating. Okay, now we come to the experiment. This is a fun part. We've got 3 yellow fever patients, and we've got 20 non-yellow fever patients, or not patients, not even. Those are non-yellow fever people. They were still living their daily lives throughout this. So we're going to take a cedar, and we're going to have it bite the yellow fever guy, who happened to die a couple years later, or a couple days later. And then we're going to give it to one of our patients and see if he gets yellow fever, which he did. This was diagnosed by a physician. We're now going to stuck the next yellow fever patient, and he actually stuck himself with this mosquito, but he didn't give any details about what happened after. So presumably he didn't have any symptoms from this mosquito. He then gave it to a different person who got mild or abortive yellow fever. So feels like the flu, not quite yellow fever type stuff. He then bit the third patient, gave it to another one of his cohorts. 5 days later, same mild symptoms. Then he stuck the same guy who died the next day with yellow fever and gave it to another guy and had basically no symptoms, but a bit later reported some uncomfortable symptoms, mild flu. Another one of his cohort people got stuck by a different mosquito that wasn't designed for that mosquito and had also some very mild symptoms. Now, unfortunately, these 2 guys who had very, very mild symptoms still had to go to work. So the conclusions that he drew from this is that cedars are likely yellow fever vectors. And he was careful to note that his results aren't conclusive, but that this should be explored more. However, the community completely rejected this idea. They were very convinced that weather and hygiene that are the vectors rather than the cedars. However, 20 years later, Walter Reed confirmed Finlay's result by making some interesting observations. Like he noticed that soldiers, if they did a rush through some mosquito areas, that they would get yellow fever more than those who did, and other lots of interesting observations. He even performed the same experiment that Finlay did, which some people died from, the yellow fever that they contracted from his experiments. But that was much more widely accepted Finlay results. So then I went to GTP to get some clarifying information. So things I asked is stuff like, is there any incorrect information in this article? And GTP correctly inferred what article I was even talking about, which is kind of cool. And he talks about some of the problems that it has was that the location of the germ wasn't actually in the stinger, it's in the saliva. He says that Finlay misidentified the mosquito species. But more importantly, he says that the conclusions of the article, the results, aren't conclusive for the mosquito. If only one of them had yellow fever. The other two were like flu, so maybe yellow fever, maybe not. And the rest were like headache and nausea. And that was it. He says that, well, that's not really quite conclusive. I also asked it information about, do mosquitoes really bite white people more than black people? And the ChatGPT says that, well, our modern idea says that mosquitoes do have preference for people on things like blood type and odors and stuff, but not necessarily color. Except if you ask Google, then the Google AI says mosquitoes prefer black people over black people, which is interesting. And then I looked through some other articles, and there seems to be a lot of controversy about this, but no one's really studying it. People don't seem that interested in that anymore. So something to know is that Finlay observed that mosquitoes were biting white people more than black people. And that's maybe that anyway, the idea is that the residents of Havana, Cuba were dark-skinned, and all the visitors were white-skinned. So the visitors were getting yellow fever a lot more dark-skinned residents, which we understand now to be more of a community thing, a mosquito biting preference. That's interesting. And then I asked it for some information on mosquitoes. Female mosquitoes will just bite in general, but they do have to be fertilized for those bites through incubation. But really, they're just biting to have fun. So. And then I asked some more interesting questions to GTP. But my conclusion from the GTP thing, I could have gotten this information anyway just by Googling. And by using GTP, I have to verify its information by Google anyway. But I didn't find GPT work very helpful in the long run. So my conclusions are that knowledge of the incubation period would have been helpful in the experiment. So if we go back and we looked at all the times, so 2 days later is when he gave the mosquito to someone, 6 days later, 2 days later, not a lot was known about the incubation period. Yellow fever, if he knew that, the experiment would have been a lot conclusive because he would know when to give people yellow fever. And then my other thought is that Finlay's results probably didn't deserve ridicule, but more exploration, because it is a good idea. He probably could have stabbed more people, could have gotten more subjects bitten by mosquitoes than just the 5 that he did. And I didn't like the post-hoc philosophizing. I thought there was too much of that. Meaning back in the day, like only a couple years previous to this, the status quo of science philosophy is that you come up with a theory based off of some observation, and then you would run pretty wild with that theory with your own ideas without any observational support for that. That's changing during this time. It's like, you know, the scientific industrial revolution, people are figuring out how to make hypotheses, that stuff. And to be careful with science. Anyway, in this paper, a bit too much post hoc extra work didn't actually produce the science he was doing. But I loved the detective work. I loved seeing how he had to look through, had to study the mosquitoes, he had to look for things to observe about why yellow fever was being spread. And it's really cool that he was able to figure out that despite the current ideas that he had, he was able to reject those, identify a new mosquito that later became true. So what are your thoughts?
I'm thinking he might have had a little trouble with being IRB.
What?
Rubow.
Oh,
Being sarcastic. All right.
Yeah, there was no IRB at that time.
No IRB.
Are these prisoners or?
No, these were, I don't know, it didn't say a whole lot about them. They're just regular people in Havana doing their regular work. So I don't know if they were local residents or if they were relatively new residents.
Did it say anything on how he got people to, he like convinced people to come possibly get yellow fever?
No,
He just found people.
he just says he has them. I'm assuming they're neighbors.
Amazon gift cards.
And I love how they still had to go to work. Right.
Despite the ethical concerns, how do you feel it shaped your ethics when it comes to if you find out something that is contrary to what common literature or other people are saying? Do you feel like it impacted how you would view results that you would come to and how you might share them with people that might disagree with you?
Were you asking how I would feel if someone came to me with interesting ethical concerns but good results?
No, like if you were to do a study and you found something based on your study that was different than the current literature, how would you go about sharing it now, reading something like this where he was ridiculed for his?
I don't know. The process is pretty set about how you can share it through journal articles and conference articles and stuff. You just got to be careful about stating your assumptions, the results. I'm not sure what I could do differently. People like it, they'll accept it, they'll reject it. People like that over time.
Do you think just maybe the ethics of it, of this could possibly save lives? Do I dare share that and go about it, or do I not? Because this would obviously be breaking a lot of ethics.
So you're asking if the results are super good, is it good to tweak ethics a little bit?
Yeah,
No.
No.
No. On the one hand, I'm assuming he got consent. They knew the risks, and they're their own people, and free choice.
And at the time, there were no governing bodies for research. They didn't exist. There were very few regulations at all, let alone regulations about what we do with participants in the research study. This is long before the syphilis, studies, long before Zimbardo and the prison experiment. Basically, all the classic ethical issues that we talk about. This was long before those. So, and clearly, it was okay to affect other people. So, I guess my point is, we've come a long way, and I think in a good way. And for the most part, IRB is a really good thing. Now, some people might get, some specific IRB officials might get a little bit, excited about, you didn't do this here or this there, and it really doesn't change anything. That annoys researchers and that sort of thing, but overall, the system is designed to protect participants and the researchers from dying of yellow fever. Or any number of other crazy things that a researcher might think, let's try this, and.
Yeah,
We
so-
should.
So Finley's cohort, we don't know who they are. I'm assuming
No.
neighbors. Walter Reed's cohort, I don't know who they are either, but they're pretty likely subordinates. And that's a bigger problem ethically. Finlay's experience, where people should publicly obey the officer. That's an interesting problem.
I just have a question, maybe you already covered this, but was it generally accepted that Walter Reed's results were accepted, but not Finley's? Maybe you explained that already.
Because he's wearing a uniform. Finley. I don't know. That could be part of it. He's a more authoritative person. He was in America. his work was probably published in more storage institutions. Maybe his cohort was bigger.
Thank you.
There is a yellow fever vaccine now, correct?
Yes.
I'm curious, if the general public had taken Finlay's study a little more seriously, if the onset of that vaccine would have come quicker as opposed to Walter Reed's, which is kind of, I guess, a hypothetical question, but like, do we think that like if people had been more like, oh yeah, maybe it is mosquitoes, we could have figured out a solution sooner?
When was the vaccine invented? Like Civil War times. A little bit before, actually. Remember reading. Use vaccine. They're like, get the pussy stuff, and they cut you open, and they put a sick person's pussy stuff in your arm. That's how they do it.
1937.
So are you talking about smallpox?
Maybe. The idea is a vaccine. While I don't. Way.
Yeah, it looks like the 1930s when the yellow fever was specifically.
Right. Oh, maybe they could have cut open some yellow fever patient, put that into some health. Use that as a vaccine. But
eventually, the issue of cause and effect for conditions related to infectious diseases, the most recent significant example of that, the finding of what causes ulcers, which was Barry Marshall, gastroenterologist, Australia, fought for years it says bacterial, and everybody else says no, it's not. Finally took a vial and drank it to prove it. So we didn't need the IV.
Wow.
Yeah.
Kurt, this is sort of along those lines. I've heard you talk a little bit about before, the idea of science today tilting toward the idea if you're a researcher who has an idea that goes against the countervailing notion of the time, that it's difficult to find funding and it's difficult to pursue your research. This ties into that. Can we talk about that for a minute?
Right, it's already somewhat present here.
Right.
I mean, people like, I think this is my opinion, okay, it's totally editorializing. People like to think that they're independent. Love to stay with the crowd. So if you have a new idea, you reject it. Just know. I mean, it's all the way back to when you're a kid and you wanted to go plant something different in the garden. Right away, got. So that's how our training is. And it's only at a point usually where you have to have enough people starting to push the, tip it over. And the grant side of things is very heavily. So every time they try to rejigger the grant system, which is the way this is going on right now, it's not the first time. Yeah, that's great, except the people who could score them are all of them. If you're not the club, you're not gonna get funded. The way it is, the club. Very, very challenging. But just don't take that as a no. If you're right, you just keep pushing.
I mean, I think that that's subtly affected by changing standards of acceptable evidence too, because like if you've got good empirics, if you do manage to somehow get it funded, like you can convince someone, rather than just, editorializing for like half of the article about things without any additional data. So like, I think empiricism does help with that some.
Or you get the data, right? You get the data and make your argument, and you have to push it. You can't just say, I published it and then go hide in the closet.
We've got 4 minutes, but Anything else for Colin, or you want to move on? All right. Move on.
Did it last year.
Why don't I just go look at it? Let's see what happens. Oh, it completely over.
Yeah.
Try to scare me over. Who else? I hate Becky. All right, I'm Rachel. I'm one of the occupational medicine residents. I plan most of you now. What else? Despite having, I should preemptively say that I have MPH, it's not FPGA, so be kind to me when we go through the steps. Also, I'm fighting between like a sympathetic response from being here and a parasympathetic response very strongly from eating tacos, so formerly known as a food coma. So we'll see what happens next episode. All right. All right. So I'm going to just give a little bit of setting. The description of the study is longitudinal assessment of kidney function in migrant workers. But I want to give you a little background on why they were did this. So chronic kidney disease is one of the fastest growing causes of both morbidity and mortality globally. I think from 1990, there's like a 92% increase. And the conventional risk factors are again advancing age, history of diabetes, hypertension or obesity, elevated lipoproteins, tobacco usage, also repeated acute kidney injuries. And one subset of this of unknown etiology occurs without these traditional risk factors. Disproportionately in young male agricultural workers, and also some evidence in similar related jobs where they're exposed to high heat stress with intensity of physical labor in occupations such as like construction and mine working. There's some other variables that they're looking out to see if these also contribute, such as agrochemicals, such as pesticides, fertilizers, also heavy metals, silica, and fructose. They're like the average soda that we're all drinking right now. So these workers had done a 2016 pilot study in the same area in Sonora, Mexico, where they observed frequent high temperatures upwards of 104 degrees, where these seasonal farm workers were working, and also observed in their urine different kinds of pesticides, as well as biomarkers indicating kidney injury. And so they wanted to do this larger study where they longitudinally assessed the kidney function of these seasonal farm workers, but as a function of pesticide exposure, heat stress, and dehydration, and working in the same area that they observed before. I actually, there's a lot of data in this paper and it's pretty done, so I really just added this for over. But this area where most of the workers are working here in Sonora, you can just compare it to the map where this red and orange area is extremely arid and very high temperature area in Mexico. So the methods they used, they recruited their participants during the same time that the farm or the company who contracted them was registering them. And they excluded participants who had a previous kidney disease or previous history of diabetes or hypertension. I guess I didn't need to say it's a prospective study because it's a longitudinal study, so that's implied. But they recruited 101 migrant or seasonal farm workers. And these were randomly selected to work in either an organic certified area or conventional area by pulling a ticket out of a box that was green or black. And then they also recruited 50 office workers at the same location as a reference group. And this was over a 6-month period. And what's kind of cool about this study is both the organic and the conventional farm fields were located in a similar area. So a lot of the exposures that these workers had were similar. So they had the workers complete surveys initially to get their demographic variables. They also, both at pre-harvest in March and late harvest, they collected urine blood samples. The urine was from first void morning samples, and blood was collected on the field. They also measured anthropometric measurements for some of the later calculations they have. That I'll show you. They also use the wet bulb globe temperature as a measure of heat stress on the human body. This is used in comparison to the heat index, and it's used more commonly by like military, OSHA, and athletic organizations because it measures heat stress under direct sunlight compared to the heat index. So they place these monitors both in the great field where the field workers were working and also in the office space. And then they use this physiological strain index, which was developed in 1991 as a measure of heat strain against the workers. And that's the calculation that they use. They obtain core temperatures and heart rate in 2 parts of where they measured these both like half an hour before the work shift, 3 hours into the work shift. And they also did a linear regression model that I'll actually talk about later, a little bit more results, because I think it's a little bit easier to kind of describe it right when you see the results. But they wound up starting with simple linear mixed effect models. And then to first look at like independently the individuals variables, and then when they found statistically significant differences in those variables, then they created these more complex models. And the models that they came up with, like I said, I'll describe a little later. And before we talk about the results, I just wanted to explain how they define the acute kidney injury. They're using the rifle classification. This is actually defined relatively recently, 2004, because internal medicine docs never had a really good explanation of what an acute injury is. And so these are the different criteria that they're looking for, and it's important to just have an understanding of what they're, for the most part, looking for is a decrease in glomerular filtration rate. And you can see here, like these rifle categories tell you different categories or levels of injury where risk is like the most minimal, and then failure toward the end. And so just get an idea of how these reductions in GFR are per category. Less than 25% for risk, less than 50% reduction in injury, and so forth. So for results, I think it's really important just to know they had a big attrition rate, 36% overall. Out of the 151 field workers, they're kind of fortunate that the amount that left was equal per group, 13 from each field group. And then additional 30 office workers also were absent during the final measurement. So there were significant differences in several of the categories that they looked at between the office workers and the field workers. And instead of giving you a huge demographics table, just listed them here. And education and income, those were higher in the office workers. The officers also were from that area of origin, whereas the field workers had come from a different state. The field workers also smoke more, they drink more alcohol, they drink more soda at a higher BMI. There were no significant differences between the field workers who started the study and left the study using their initial data. There were some differences though, in the office workers who left, who were mostly older, had higher BMIs, and higher blood pressure. Excuse me. So this is the graph, one of the few graphs in the study. And here they're showing only one of the initial DFR rates here. 127 was actually equal between the organic and the conventional field workers. And you see that with the purple, that the office workers actually had not significant, but even improvement in DFR from the initial measurement to the late harvest measurement. Whereas for both of the groups, the field worker group, it went down. Here, they're looking at, excuse me, which groups, had these different levels of rifle criteria, acute kidney injury. So they noticed that among the workers in the organic group, there were 4 with this decrease in DFR greater than 25%, 8 within the conventional group. Within the conventional group, they also saw 2 workers with a reduction of more than 50%, and they saw none of this among the office workers. They also noticed, and I should explain that too, for the field workers working in the conventional field, they noticed 8 workers who had DFRs less than 90. And they didn't see that in any of the other 2 groups. What's significant about this is a DFR less than 90 is actually at least stage 2 chronic kidney. So that's kind of a little different from acute kidney disease, which can be temporary, whereas chronic kidney disease, may take decades. So that number below 90 is, it's not random that they chose that. And you can see in one of these that how significant that change was from 120 to 33. 33 is actually like stage 3 chronic kidney disease. So that's pretty significant. I don't think you need to go. Oh, sorry. I don't want you to have to go through all of these. But just to give an idea, here they were looking at comparisons longitudinally with the individual workers themselves. And just also notice that aside from the drop in the DFR, both of the field worker groups, there are also significant changes in other biomarkers that are associated with kidney problems, kidney disease. So increases in creatinine, uric acid, so forth. And also toward the bottom, also notice significant changes, increases in metabolic work rate and the physiological strain index that they had calculated, which they did not see in the office workers. So for the regression models, I think I mentioned they started with simple linear regression models to identify like independently which individual variables had effects on eGFR. GFR was their dependent variable in all the models, and they came up with 4 models. The first model was over the, so the things that they wound up kind of identifying were the different models were heat strain, dehydration, and the job category kind of like as a proxy for pesticide exposure. In the first model, they looked at time, and they were looking, I think, particularly to evaluate how DFR change between the pre-harvest and harvest. And after adjusting for the other variables that they looked at, like education and so forth, they did see a significant difference, both overall, I think, which is listed here, as well within the field worker group. In the second model, they looked at the physiological stress index, the self-reported water intake, and dehydration. And again, after controlling for the other variables, they saw 1% increment in the PSI for every decrease in GFR of 16. And they also noticed that patients or participants with mild dehydration also had a significant decrease in GFR. In the third model, they were looking at both the job category, which again, as a proxy for pesticide exposure, and also insecticide application inside homes and dormitories, because they had noticed that there was a significant difference with the amount of insecticide that the field workers had used in their dorms compared to the office workers, which had minimal use. And again, they saw significant decreases in the GFR among the field workers compared to the office workers, both in the organic field and the conventional field. They didn't compare to bench the organic versus the conventional in this model. And then the fourth model, the main variables are here for the physiological stress index. Actually, the fourth model was all the variables together. And so initially they saw like a 1% increment in the physical stress index among the field workers in both the organic and the conventional field. But when they accounted for all the covariates, they didn't see the association anymore in terms of the job category. So just to kind of summarize, they did see a significant decrease in kidney function, using the DFRs among the field workers from pre-harvest to late harvest, and no significant change in the office workers. They also saw, apparently corresponding to that, increases in both systolic blood pressure as well as some of the biomarkers that indicate kidney stress. The field workers also had a decline in DFR below 90 with the one graph I showed you, only in the conventional field, not in the organic field. And as I said, that's associated with at least like stage 2 chronic kidney disease. And there was also a significant association between heat strain measured by the physiological stress index, along with dehydration. So for strength, I thought this was a really unique working site to be able to compare the work groups on the 2 different types of fields where almost everything around them, they were drinking they had access to the same like supplies, they were living in the same dorms, food, and work in the same area. It was a longitudinal study, so I think that's a good way to study this because you're measuring values over time. And then they did do a sensitivity analysis, and the results from that were similar to a validated model. So one of the things I didn't mention was they used a p-value of 0.2, which for me, I think suggests that this is still more of an exploratory kind of study, because that's a little bit of I don't know. And what you guys think about that? Maybe we can kind of start the discussion right now. Are there any other strengths that you can think of for the study? We'll move on. Think of next bit. Okay, weaknesses. Everybody in the summer was male, so this is limited to male workers. The race adjustment factors that they used in the GFR calculation. What's nice about what they were able to use was, the calculation was based off of evidence, between different races, because that's been a problem for a while. Coming up with the right GFR depending on your race. So they were able to do that for like native workers and I think Latino workers. But that calculation was validated in the US, so it may not be relevant to this population of Mexico. And then we saw a lot of significant differences between the field worker group and the comparison office group. I also didn't put it here because they're gonna start this off again as a discussion, but there's a significant about a lot of people dropped out of the study. And so that may also have been another factor, particularly since the people from the office group who had left were a little bit, they were a little bit more like the field worker group. Any other weaknesses? I don't have that thought. All right, for discussion, and I'm sorry, I know the paper is a little bit dry. I chose it just because it's over stuff that I'm interested in. But I know there's a lot of numbers in the calculation study. But I think for my discussion questions, a lot of the relevant to the fact that I think a third of the people in here are like pro epidemiology and biotech classes, including myself. So I thought it might be interesting to talk about what kind of study it actually was. It was a longitudinal study, but do you think this was also like an epidemiological study, or do you think it was a random book? Based on how it was.
I'm looking around, but you know, just.
I would say it's good to have a PhD in here. That's fine. Please.
Someone just take it. Come on,
Sure.
50-50.
Aren't random controlled trials epidemiological studies? Like, I'm confused why we're comparing these two things.
Because I think of epidemiology studies as being more observation studies. People, you have groups of people, but then they do what they do, what results are. And then a random controlled trial, you have an intervention. So my question with this is, you know, so first of all, is it prospective or retrospective? That part's easy. Right. So it's forward, right? Not backward, not looking at data backward. Was there a randomization? No. Well, there was, right?
Mhm.
So the workers who were field workers were randomized into organic versus conventional field. But is that a medication? No, it's an exposure. So the reason I had this question was, I'm not quite sure. It's a little bit of, so I'm hoping our experts would help us out with this. So I think this is more of an epidemiology study. You know, we're not looking at our randomization isn't like an intervention where we're trying to, you know, find out if like a drug has efficacy against something, a vaccine. And I think, you know, the workers were going to work in, well, anyway, so I think this is more of an, is there anybody who, what would you say about that?
I would go for a differentiation between an observational study and an interventional study.
Yeah.
Right? So, and you're right, there is some random assignment of exposure, right? Where and I wasn't clear if it was the researcher doing that or if that was, right? I think
That was random. So at the start, you know, the people were enrolled at the same time that the company was asking for. So they were doing it about the same time. And so for the randomization, the workers, you know, after they've been excluded, you know, if they'd had like, you know, prior history of kidney disease, hypertension. So after they were selected, then they stuck their hand in a box full of cat. It was green, black. If it was green, they went to the organic field. If it was black, they were kicked. How they got the company to do that?
but that was for research purposes, not like the company wasn't
Nope.
doing that, you know what I mean? So to me, I would say it's an interventional study
Okay, so
there,
Okay.
because even though it's weirdly,
weird design, right?
Yeah, it's sort of an odd design, but
I'm glad you think it's a great design.
unique, we'll say unique.
All right, I mean, how did obtaining longitudinal data benefit from the study? I do think, there was advantage there. I think there's an advantage when we're able to compare like biomarkers or values from one to the first. Do you think there are any drawbacks to that though?
I don't necessarily know if this is the most accurate, but I was a little bit surprised to see that they did linear regression. And I don't know exactly if they go into the details, but I feel like for having two different time points, linear regression normally I thought was supposed to be more dependent. So I don't know, I thought it was interesting. They could have done like a mean score predicted and all that, but I thought I potentially would have done a different type of analysis. Not that theirs was bad, but I was surprised by that.
I was a little bit too, actually. I'm happy to read about. Do I think that's so clear that? I think it's partly because they had I don't know if you call it a nested group per se, but like a case control, but it was almost like that where you had this, then two different randomized groups for the other group. I don't know. That's kind of how they were working, but I agree. Okay, yeah,
You mentioned that they had a lot of people drop out of the study.
they did.
And so I was assuming that's because of how long it was, so it makes it harder to get all your data points and it just suddenly makes your sample size so much smaller.
So I agree. I think that was a real disadvantage. I think that's one of the troubles with longitudinal studies too, where you have higher risk.
So, they don't really justify selecting a P as less than 0.2,
No,
and that's a
it's
problem.
weird.
I think what happened was they had so much attrition that they didn't have enough power to actually detect the effects that they thought they were gonna see. And they probably would have seen an effect if they had had enough people. And so they don't have statistical significance. They might have practical significance, but
I wonder
the
about
only way to
like
do, you can justify a 0.1 if you have a strong directional hypothesis and you do not believe it has another direction, but you can't go to 0.2. That's just weird.
it
and-
seems, yeah.
You're more likely to make errors.
I think I agree that it's weird. I also don't assume that the dropouts are random and that they're
Yeah.
just
Yeah.
reducing your statistical power. Because they could have not been random,
Yep.
and been very selective one direction or another, and then
Yep.
I would be very cautious about saying, yeah, there may be something there if we would have gone to 0.1, it could have, it just really.
Maybe they dropped it because their kidneys failed.
Yeah.
I wonder about that.
Like, you don't know, maybe they're
They-
stuck in bed, right? They're getting a kidney transplant, no,
Or they had end-stage renal disease killed over.
Right? I mean, there's other things that exposure to pesticides at high levels can do to a person besides kidney failure. You
So
know?
when you have large
So-
dropouts, it can completely invalidate any results.
Yeah.
And you need to keep that in mind going forward.
They didn't really discuss that a whole lot, I think, in the discussion either, which I didn't like that. I thought that was a little bit, you could at least discuss it. Yeah. That actually, oh, yeah,
I don't know if this is, but this says that most of the workers were from Puebla and Chiapas. but they're
Yeah.
in Sonora.
so those are
Those are two different
southeast. And then compared to northwest, which, so they were from much more milder climate. Yeah. But I would still think over 6 months. Over 6 months, you might, they might adjust to that or not. I mean, potentially though, that might be the reason why they left. They're like, I want to go home. I don't.
Talking about kidney function.
And attrition, just because if it was a 6-month thing, growing seasons are vary and harvesting changes, and the company may have said, we don't need as many workers, for the next 2 months, so people went back home and then maybe they came back, so there's just a lot of unknowns about how their sample, kind of ended up being.
Their wording was also kind of weird when they said, I think it was like 20, the office order just didn't show. they didn't why that was the company who create them. I mean, it could have been a lot of. The other thing I have in one of my later questions too is whether the Rifer criteria was appropriate for this, because it is for acute kidney injury, which is acute. They're looking at the values that heart. That's not like an acute timeframe. And I think that's partially gets to like what Troy was getting. You know, it's possible these workers were used to a different climate. Maybe when they first got there, maybe a few weeks later, they were already having problems. We don't know. I think one of the ways this study could have benefited was from getting more values, you know, like every month or every 2 weeks instead of one to the start. Anybody else? I don't know if
You know, I think there was a lot of benefit to making this a prospective longitudinal study, but the question that I'm curious about is, we've demonstrated that this group of workers had a decrease in their GFR over this 6 months. But how many seasons are they doing this? And again, this doesn't, I don't think, meet the criteria as an for an AKI, right? Because it's not acute. We do know that like if you have multiple repeat AKIs, then that puts you at risk for CKD, but how many seasons are these workers like doing this labor? How often are they having like, you know, maybe this transient increase in their or decrease in their GFR? And in that case, I think it would be interesting to look at more of a retrospective study. Again, that will have its flaws and its challenges, but if you look at like, you know, a sampling of workers who are healthy and of workers who have developed CKD, you can maybe learn a little bit more than you would from this prospective study.
Yeah. I think there were no differences in age, at least between the groups. I mean, statistically, but that's actually a good point too. It might have been worthwhile to add like the youths that have been doing this, you know. I think in terms of this CKD or chronic kidney disease of unknown origin, it sounds like just reading the literature, my assumption, you know, not anecdotal, but my assumption is that a lot of this repeated dehydration is causing like a pre-renal AKI over and over again. That's what's causing the chronic kidney disease to go from acute to chronic over time. So yeah, I think that would be a good idea, or at least, or even to combine that, you know, with the studies somehow. I don't know if we're running out of time.
I think we're right about time, so maybe, and if anyone has anything else, or I think we've got about 1-2 minutes.
Let me see if any of these questions.
I mean, I pile on the issue that the groups are very different.
Yeah, yeah.
Right. This area, Mexico is very close to the Gila Indians. Gila Indians have like 50% diabetes. So there's this potential for a confounding situation. That's not. We just don't know. It's very interesting study, sir.
I was thinking along those lines too, that just because a lot of these people have been diagnosed with diabetes or hypertension, doesn't happen too, right? So, you said, and some of the differences between office workers, the farm worker groups were really important too. There are things like drinking soda, drinking alcohol, smoking, all things that are, you know, associated with kidney injuries. So.
We're also assuming equilibration with 24 hours. I testing more.
Yeah.
Which actually that's really improved. Certainly mostly equilibrate. All you have to do is not totally, you'll have variances which are really not, they're gonna be there, but they really don't have fees. So.
They said that they did that. They said all the fluid balance of the body would equilibrate. I don't know how accurate that is. But they tried to. All right. I think that's about it. All right. Yep.
Before we leave real quickly, I wanted to head over to Kevin just for like 2 minutes. He's got an announcement regarding something very fun.
Yeah, I will be very brief. I know we're already over time. So for those of you who don't know me, my name is Kevin Connor. I'm a postdoc here. And for the last couple of years, I've run a writing group for some of the graduate students. I'm casting a little bit wider net this year, so if you're interested in joining the writing group, come talk to me after this or send me an email. Basically, we meet every other week. One person agrees to share a piece of writing they're working on, dissertation chapter, thesis proposal, something like that. Everyone reads it before the meeting and then we spend about an hour discussing it. It's a really great way to improve as a writer, but it's also a really good commitment device if you're staring down the barrel of a semester where you really need to get some research done. It gives you an audience and kind of a low pressure venue to share that in. So if you're interested, let me know.